rational function is improper and a proper function is there. Okay, so when we can say the rational function is a called proper rational function or improper rational function, it's very simple, students. Every rational function can be given by, I'm taking p of x by q of x. Okay, p of x and q of x are any two polynomials, right? I'm going to give some example of proper and improper functions here. Actually, the degree of p of x must be lesser than degree of q of x. Then the given rational function is called proper rational function. So degree of same p of x is greater than p of x, nothing but what is p of x here? Numerator. This is denominator. So what do you observe, students? Degree of numerator is greater than degree of denominator. Simply have written like this. Degree of numerator means degree of p of x is greater than degree of q of x. Then it is called improper, right? This, if it is a proper rational function, then only we can apply this partial fraction. What is the mean by partial fraction? I can explain you. Okay, if it is a proper function, we can apply the fractional part like partial fraction method. If it is improper rational functions, so what shall we do? That improper rational function, that is p of x by q of x, we can change it to proper function. For example, I'm going to give some example which is regarding to proper and improper. Example, yeah, x by x plus 1, x plus 2 is there. Is it a proper function or improper function? It is a proper, because degree of numerator is 1, but whereas degree of denominator x into x square. Okay, nothing but degree is here 2. Degree of numerator is 1, degree of denominator is 2. Clearly, it is 1 is lesser than 2. 1 is lesser than 2. It is a proper. So coming to improper example for improper rational function, it is a rational function. Yes, sir, numerator is a polynomial, denominator is a polynomial. So when I take a same example, but instead of x, I'm taking x cube. Okay, students, what about this function? Is it a proper rational function? No. So what is the degree of numerator? 3. What is the degree of denominator? X into x square to 2. So clearly here 3 is greater than 2, so that this function is improper. The degree of numerator is greater than the degree of denominator. So this improper function, we can make them to proper function by using long division method. Like if I multiply here, so how to use long division method? Like see here in exercises also, already we discussed that whether partial fraction is applicable or not. So here, take the question number 12. Here, let us see the question number 12. Question number 12, what is the degree of numerator? 3. What is the degree of denominator? 2. So it is an improper function. We can make them to proper function by which method? Long division method. So what is the mean by long division method? How to apply that? So first you have to take numerator x cube plus x plus 1. This numerator we can dividing with the denominator. So what is the denominator here? Denominator is x square minus 1. long division method. So here multiply with x square into x cube, minus 1 into x minus x by minus into minus plus, it cancel. So here x plus x, 2x plus 1. Now, so see students here, if the function is improper, p of x by q of x, if it is an improper function, this is equal to, you should write here like uh, some function like capital Q of x plus I'm taking capital P1 of x by Q1 of x, like that. This we know that how to write here. Okay, how to write. So how to write, students, here? This function, it can be written as with help of this. Yes, anyone?
X plus 2x plus 1 by x square minus 1.
X square bar. Exactly, exactly. This is the quotient. So here P1 of x, the remainder by the divisor. Okay, dividend we can divide with the divisor, so we get a quotient. So like that we'll write. So now here observe here, students, what is the degree of, now we change it to proper. This is a proper rational function. Degree of numerator is 1, degree of denominator is 2. Now you can apply the partial fraction method.
Sir, can you explain how to write it again in a proper form?
A proper one with this example. Okay, this is dividend, this is divisor. So divide the numerator with the denominator, we get a quotient. See, x square is there, but it is, I'll write the proper steps, no problem, but I'm giving some example for improper rational function, then how to convert to proper with the help of long division method, right? So here x cube is there. To get x cube, how much we can multiply to x square? So we can multiply to x square with x. So I'm taking here x square into x cube minus 1 into x is minus x. So I'm taking here, I'm subtracting here minus into minus plus, x cube cancel. X plus x 2x, and remaining one I have written as it is. Here there is a property. If you take, this is capital Q of x. This is remainder. Like you can take a capital R1 also. This is remainder. The remainder I'm taking as R1x. So this is like I'm taking Q on x. So this, the quotient is dividend by divisor is equal to quotient plus remainder by the divisor. Okay, okay. First this you can write x plus and remainder by this divisor. Okay, so after that we'll okay, so like that, this is a proper. Let us do again. Any other function here, only just one function alone is there, that improper. Remaining all are okay. Here we'll do some by substitution method, we'll do it, because numerator degree is equal to denominator degree. Degree is same. So other than these two questions, in remaining all the question, mostly the all are proper rational functions only. All are proper rational functions. Proper rational functions. Okay, like, right, students. So in partial fractions, before applying the partial fraction, what does it mean by partial fraction? If it is a proper function, if it is a proper rational function, sorry, proper rational functions. Proper rational function means degree of numerator is lesser than denominator. In that case, so it may be the denominator is the product of maybe linear or quadratic expressions. These are all are linear expressions. So this is quadratic expression into linear expression. Here this is a linear expressions and quadratic linear, like that. Almost quadratic linear. We don't have any cubic. If it is a cubic, here cubic is there, we can convert it into the product of linear and quadratic. So they split into simpler rational function. This is a product of two linear function, which is equal to, we can write a simpler rational function like a by x plus 1 plus b by x plus 2. Don't think about numerator whatever it is. It may be 3x minus 1, it may be 2x, 1 minus x square, whatever it is. Okay, this is the way of doing partial. After, see, like that, we need to find a comma b, then we can integrate, because if we cannot integrate direct any question here. Can you integrate here? Here there are nearly 2 or 3 functions are there. When you see here, there are 2 functions, 1 by x minus 1, x by x minus 2, 1 by x minus 3, product of 3 function. Is there any u, v, w formula? No. In case here you are having 2 different functions, fine. Here you are having 2 different functions. You may consider one is 1 by x plus 1, another one is x by x plus 2. Can you able to apply UV rule? Okay, if you want to apply UV rule, what is u, what is v? Do you know that? Both will be algebraic function, like the product of linear. What you will consider as u, what you will consider as v? No, we don't know that. Both will be equal. So that in that cases, see here, almost all the question based on a quadratic expression, a linear expression. Other than, is it involving any other function like a logarithmic function, exponential, trigonometric? Yes. Here few questions are there. Like 17th question is there. It's depending on like they have given in terms of cos and sine. Clearly they have given inter. By taking sin x is equal to t, when I take sin x is equal to t, cos x dx is equal to dt. Nothing but this cos x dx becomes dt numerator. So dt by 1 minus t, 2 minus t. Now what do you observe? Again, this is the product of 2 linear expression. So here we can apply only partial fraction. It's not involving. So whenever you want to apply the partial fraction, it should be a expression of linear and quadratic. It should not be depending on any other inverse trigonometry, logarithmic, e power x, like that. So partial fraction cannot be applicable for any other function other than linear expression, quadratic expression. Okay, students. Okay, let us do. So this is like partial fraction is easiest concept to compare to others, but finding a comma b values are important after splitting into 2 terms, right? If you do one problem, you'll get complete idea. I'm taking the first one. The first question. I is equal to integral of 1 by x plus 1 in, sorry, 1 by not 1 by or x by x by x plus 1 x plus 2 into dx. Right, students? Okay, fine. Now this is, you can take as equation 1. You can take this as equation 1. Okay, I'm taking, what is the integrand they have given? X by this. This is the integrand. I'm taking now integrand alone. It is clearly a, you may write like this. You may write like this if you want to write the steps clearly. The integrand is a proper rational function. Then let us take this integrand. x by x plus 1 into x plus 2 is equal to, see here, a product of two rational function. Then what shall we do here? A by x plus b by x plus 2. A by x plus 1 plus b by x plus 2. Right, let us take this is equation 2. Next, what I want to do is, here I want to take LCM on RHS. So x by x plus 1, x plus 2. Okay, concentrate student, in all the question will do same procedure. Like, okay, like RHS is x plus 1, x plus 2 is the LCM. You can cross multiply here A into x plus 1 plus B in, sorry, x plus 2, B into x plus 1. Okay, after this, I'm going to cancel the denominator. Yeah, denominator gets cancelled. So x is equal to a into like if you multiply here, if you multiply with a here, ax plus 2a, ax plus 2a, bx plus b will get like this. Now see LHS, here we are having x, there is no constant I'm taking as 0. So now you can take x common, so here a plus b into x. Remaining constant is 2a plus b. So actually what is the left side? X. There is no constant, I'm taking as 0. Now all of you comparing on both side x coefficient. So what is the x coefficient here? Left side? Yes, students, 1 into x. X coefficient is 1 and constant is 0. Now comparing on both sides, here a plus b is equal to 1. Am I right? Here a plus b is equal to your x coefficient 1. And another equation 2a plus b. Constant is right side is 2a plus b. Left side there is no constant, you can take as 0. Now is it difficult to find a comma b solving these two equations? Minus, minus, minus. So here b get cancelled. Now here a minus 2a, that is minus a is equal to 1, which implies a is equal to minus 1. So this is the value of a. In the same way, you can find the value of b from here. A plus b is equal to 1, which implies b is equal to 1 minus a. B is equal to 1 minus of minus 1. B is equal to 2. Clear, students? Here we got A value and B value, right? After getting A and B, substitute those values in equation 2. So what is equation 2? LHS x by LHS is x by x plus 1, x plus 2. Right side is a by x plus 1 plus b by x plus 2. What I have written? A by x plus 1, b by, I replaced a and b values. After that, what is, okay, this is the given question like x by x plus 1. So we can find the integral of this value. So take integral dx. When I take integral dx, when I take integral dx, like this. So this is nothing but a given question I'm taking as I. So right side minus is, you can take minus outside 1 by x plus 1 into dx. 2 is a constant, take it outside 1 by x plus 2 into dx. Now since we know that it is in the form of 1 by x, 1 by x means log of x plus 1 plus 2 times of log of x plus 2. Fine. So first I'm going to write this plus value like positive plus 2 times of. See student, this is in the form of m log a. M log a. M log a. What is the formula for m log a?
Log A
log
over here.
log a power n. Okay, fine. So log x plus 2 all to the power of 2 minus this log of x plus 1. See students, again it is in the form of log a. Let us consider this total is log a, this is log b. Log a minus log b. Yeah, you may take constant here, plus c. I want to take plus c. The constant is plus c, no problem. So the answer is log of this a, log a minus log a by b by log x plus 1. Okay, this is the answer. You may write plus c or else into c, because after that, let us consider this whole term as a, this as b, log a plus log b, log ab. Okay, right. This is the required answer. Okay.
Sir, we can also
Hello.
write as plus C, sir.
Yeah, you can write. That's your wish. It is a constant. You may write plus c or sin c, cos c, 100 c, 1000 c, no problem. Constant, whatever you can take. Yeah, you can take plus c. In place of constant, you should take any value, but don't take particular value. See, constant, 100 is a constant. You should not take 100. You should not take 1. You should not take 0. But you can take like arbitrary constant like c, d, like that. C, you can take c. You can take c square. You can take e power c square, log c, sin c. Okay, no problem at all. But don't take any particular value like 1, 2, 3, like that, because it is a indefinite integration, so that you can take arbitrary constant, right students? C plus c. Fine. So this is the answer. Understood? First we have to check whether the given integrand is proper or improper. Proper or improper. Okay, next step. Next one, this question, second question, you can do it. Second question, you may do in different way. See students, actually this is directly in standard form. In exam, they given this question, you can write x square minus 3 square. It is in direct standard integration. What is the formula, students? It is in the form of like integral 1 by x square minus a square. This is equal to 1 by 2a log mod x minus a by x plus a. Am I right? You can use directly. But if they mention like using partial fraction, particularly this question, like how to do this, you can write first, you can write 9 as 3 square, x minus 3 into x plus 3. Same, this is equal to a by x minus 3 plus b by x plus 3. Like that you can do. Okay, next I'm going to do a third one or else any other. Third one also same. Third one is x minus 1, x minus. So 3x minus 1 by, okay, third one. I is equal to integral of 3x minus 1 by x minus 1, x minus 2, x minus 3 into dx. Let us take this as equation 1. Just you have to take that integrand alone. It is clearly proper rational function because numerator degree is lesser than the degree of denominator. So we can easily write the sum of the simpler fractional like rational function. Like see here, shall I write here a by, so this is all are linear expressions only. A by x minus 1 plus b by x minus 2 plus c by x minus, split into different function. Now let us take this as equation 2. See, after this step, same common procedure, take LCM. What is LCM here? X minus 1, x minus 2, x minus 3. Now here, a into x minus 2, x minus 3 plus b times of x minus 1, x minus 3 plus c times of x minus 1, x minus 2. Now see here. Uh, so what about here? Uh, 3x minus 1 by this x minus 1, x minus 2, x minus 3. So get cancelled. Denominator get cancelled. Now you have to equating this 3x minus 1 is equal to, you may multiply this, or else, this is, I'm going to explain you another method. So say multiply and compare the coefficient of x and x square. This is, that is method one. We have used in here. I multiply with x a here, multiply a here, and I'm taking like comparing on both side x coefficient and constant. We got two equation. Okay, this is one way. But here three values we need to find: x minus 1, x minus 3, plus b into x minus 1, x minus 3. Sorry, this is x minus 2. C times of x minus 1, x minus 2. See students, now let us take this is 3. Now look at here. I want to find, I'm not multiplying with a, I'm not multiplying these values. I want to find a, b, c value by substituting suitable values of x. The suitable values of x I want to substitute, and for example, to find capital A value, I want to make them b and c value 0. It is possible or not? Yes, it is possible. Possibility is there here. So here, what is the common factor for second term and third term? X minus 1 is there. Here x minus 1 is there. When I substitute, when I take x is equal to 1, what about the second term and third term? Put x is equal to 1 in equation 3, both sides. So 3 into 1 minus 1 is equal to a into 1 minus 2 into 1 minus 3. Then what about b value, Amma? 1 minus 1, 0 minus 2, plus c into 1 minus 1, 0 into minus 1. Final anyhow. So here left side is 2 is equal to right side 1 minus 2, 1 minus 3, minus 1 minus 2, 2a. Remaining value 0 plus 0. See, I make them b and c is 0 by substituting suitable values of x. So which implies a is equal to 1. Okay, this is called method 2. Okay, you may approach here also. You can multiply these two, multiply these two, multiply these two. You'll get x square coefficient, x coefficient, and constant. Comparing on both sides, you can solve the equation. Instead of that, there will
Sir,
be, yeah.
sir, for finding A, B, and C, we can take like A is equal to we can solve f of a1 by a1 minus a2, a1 minus a3, sir.
F of a1.
Sir, f of a1 by a1 minus a2 into a1 minus a3. Like a1 is 1, a2 is 2, a3 is 3.
You want to take here capital A, B, C values.
So no, sir, for finding each values.
Okay. Here. So here, what is the function actually? Function is not there, no?
So 3x minus 1.
Okay, 3x minus 1. See, okay. Here actually in equation 3, you can give any value of x. You might give x is equal to 0, 1, 2, 3. We are going to get different equations. But what I'm telling, you may substitute 2, 3, 4, minus 1, minus 2, minus 3, whatever it is. You'll get different equation. You can solve both, all the equation. But instead of that, this kind of questions, uh, like we can easily make them that to find a value, we can easily make them b and c is 0. To find b value, we can easily make them a and c is 0. To find c, we can easily make them like a and b is 0. Possibility is there. If there is no any possibility, like that's your wish. You can give randomly values 0, 1. You'll get some equations in terms of a, b, c. You can solve them. Okay.
Okay.
Okay, for what value of x? Okay, we got a value. For what value of x, a and c becomes 0? A and c becomes 0. What is the common factor?
2.
2. So x is equal to 2. When you take x is equal to 2, substitute x is equal to 2 in LHS. So 3 times of 2, 2 minus 1 is equal to a into 0. A becomes 0, but b alone 2 minus 1, 2 minus 3 plus c into 0. Directly it will become 0. 2 minus 2, 0. Like, okay, so here 6 minus 1, 5 is equal to 0 plus 2 minus 1, 1. Okay, so this is minus b will get plus 0. So b is equal to minus 5. Am I right, students? So b value is minus 5. And what is c value? To find the c value, we can make them a and b 0. What is the common factor? X minus 3, x minus 3. Am I right? So we can take x is equal to 3. Put x is equal to 3. X is equal to 3 in equation 3. So LHS is 3x minus 1. 3 into 3 minus 1 is equal to a into 0 plus b into 0 plus c into, what is c value? X minus 1 into x minus 2. So that is 3 minus 1 into 3 minus 2. So here 9 minus 1 is 8 is equal to 0 plus 0. Here 3 minus 1, 3 minus 2 becomes, I think, 2c. C is equal to 4. So after getting these values, A, B, C values, this A, B, C value substitute in equation 2. A, B, C value substitute in equation 2. So whenever it is a linear expression, so mostly you are going to get log of this denominator. So what is the A value we got it, students? A, B, C value, A value 1, B value minus 5. 1 minus 5, 4. Here it is 1. Here A value is 1. This is minus 5. Here 4. After getting this, simple. So what shall we do here? Integrate on both sides. This is the given integral, 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 integral. See 1 by x minus 1. The answer is log of x minus 1. Here 5 minus 5 is a constant, take it outside. Log of x minus 2. Yeah, 4 is a constant, take it outside. 4 into log of x minus 3. So this is m log a form, here m log a form. This and all you can simplify. So this is the way of finding, evaluating the integral of given rational function. This and all you can do. After finding a, b, c value, substitute in equation 2. Simplification and all you know very well. Okay. Fine. Next, coming to, I'm going to take any quadratic expression. So you can do fourth one. You can do even fifth one also. Fifth one first, you can write the product of linear expression. So whenever you having product of two different expression, then only we can split into, we can apply the partial fraction. Is there any two function? Only one function is given. Only one expression is there. To apply the partial fraction, minimum we require two product of two functions. We having single, so that here it can be written as x plus 1 into x plus 2. X plus 1 into x plus 2 becomes x square plus 3x plus 2. This, okay, after that you can write a by x plus 1, b by x plus 2. That and all you can do. And sixth one also I'll explain you, no problem. So seventh one is one quadratic expression is there. One quadratic expression is there. So let's see here. Seventh one is.
Sir, can you stall up 1 minute, sir?
Sorry.
Okay, sir.
Okay, students. Seventh one is I is equal to integral of x by x square plus 1, x square plus 1 into x minus 1 into dx. Okay, right. Let us take this as equation 1. Okay, in equation 1, you may write this step. In equation 1, clearly, the integrand is a proper rational function let. Like that, you may write this step. Then after, now take the integrand at x by x square plus 1, x minus 1. This is equal to, right, straight. First one is a quadratic expression. Quadratic expression. For every quadratic expression, you should write the numerator as a linear expression, x square plus 1. If the denominator is a quadratic expression, numerator must be a linear expression. So denominator is x minus 1, numerator is just a constant. Because the derivative of quadratic expression becomes linear expression. The derivative of linear expression becomes constant. So that we'll write like this. Okay, fine. So quadratic expression, every quadratic expression we can write. Here also same pressure, again same pressure. Take LCM, x square plus 1, x minus 1. So here ax plus b into x minus 1 plus c into x square plus 1. That's all. So here left side is x by x square plus 1, x minus 1. So now again the LHS RHS denominator get cancelled. So we are going to get equation 3, that is x is equal to, okay, ax plus b times of x minus 1 plus c into x square plus 1. Okay, student, I'll do. Let us take this is 3. Up to here, it is very clear to everyone. Now, here also same thing. To find a comma b comma c, I'm going to substitute suitable values of x. First, I'm going to find c value. To find c value, I want to make them with ax plus b becomes 0. For what value of x, this total value becomes 0, students? Yes? Put x is equal to? 1. That's all. When I take x is equal to 1, 1 is equal to a into 1 plus b into 1 minus 1 means 0 plus c into 1 square plus 1. Okay, that's nothing but here 1 is equal to 0 plus 2c. So which implies c is equal to 1 by 2. That's all. Okay, we got it to c value. After getting c value, I want to find b value. To find b value, what is the value you want to substitute? See, already we got the c value. C, in place of c, you can replace 1 by 2. No problem. I want to make them a value 0. How can you make a value 0?
X is equal to 0.
That's all. X is equal to 0. So 0 is equal to a into 0 plus b into 0 minus 1 plus c. Already we got it. C value is 1 by 2, 0 square plus 1. You can replace c value. So is it possible to, we can make them to find b value, a and c become 0. C should not be 0 for any value of x because square is there. Okay. So that first I found c value, then I replace c value. Now here b into minus 1, 0 is equal to minus b plus 1 by 2. So b is equal to 1 by 2. After finding a comma b, to find a value, you can substitute any value of x. Already we got b value and c value. So how to find a value? Take randomly any value of x. So what shall we take x value? Put x is equal to, but you should take a small value. Don't take a large values. So I want to take x is equal to minus 1. You should not take minus 1. You can take minus 1 or plus 2. That's your wish. I want to take 2. Let's see. When I take 2, your LHS is 2 is equal to, so 2 is equal to ax, that is 2a plus b. What is the b value we got is 2 into 2 minus 1 plus c. C value is 1 by 2. 1 by 2 or minus 1 by 2? 1 by 2 only. And c into x square plus 1, that is 2 square plus 1. Okay, student. Right. Next step. So 2 is equal to 2 minus 1 is 1, 2a plus 1 by 2 plus 5 by 2. So 2a is equal to 2. Yeah, what is this value? 2a plus 1 by 2, 5 by 2, 6 by 2, that is 3. 2a is equal to 2 minus 3, that is minus 1. So a is equal to minus 1 by 2. Is it right? So now this a, b, c values, after getting a, b, c values, substitute in equation 2, a value. So we are getting here, we are going to get x by, means given integrand, so is equal to a value minus 1 by 2. So integral of minus 1 by 2 x plus 1 by 2 pi x square plus 1 plus 1 by 2 by x minus 1. Okay, so now into dx. So now see, 1 by 2 is a constant. You can take it outside, and you may do, you can evaluate. Now onwards you'll get very easy. So this, you know very well how to integrate this. Okay, students?
Sir, can you solve one, sir?
Yeah. Student, till yesterday class, I posted all the recorded videos as well as slides.